What's good, guys? Let's make a quick video today because I'm gonna be a little bit busy later today, so I'm gonna get it out the way. This problem is not on LeetCode, or it is, but it's paid, so I'll have to do it on this one. Welcome to day 209, I think. We only have about like 13 minutes, so let's see if I can solve this as quickly as I can. Given an n nodes labeled from 0 to n minus 1, a list of undirected edge. Each edge is a pair of nodes. Okay, so they go both ways, I guess. Since all edges are directed, okay, makes sense. Basically, I can construct, I should basically construct the graph, and then if I can pick a source, right, and if one of them leads me to a place I want, meaning all the nodes, which is 0 to n minus 1. So then I have a valid tree. So So actually, let's start with that. For every source in range of n, right? If I guess we could do DFS or BFS. Let's do BFS because it's a little bit easier, right? Source. Then return true. False, something like that. So we're gonna do BFS, which will take in a source, probably a scene, and yeah, let's get to it. So let's Q, DQ, while let's do while Q. Probably should put the first element, which is the source. Also, I should probably construct the graph. Let's do that. Construct the graph, which is for every node to. Alright, I guess for every vertice I don't know what the difference is. UV in edges. We can do graph. We could have default. Which is the list graph of u dot append v, and then we do the opposite as well because they go both ways. So that's cool to see. And then so while q, at the source, cur is equal to q dot pop left. Yep, and then so cur equals q dot pop left. Write a function to check whether these edges make up a valid tree. Okay, so to traverse it, I guess we would check its neighbors. Or first we can add it to the scene. Dot add cur. I guess if cur in scene, I guess we could return false immediately. And then or I guess we can traverse the. Actually, we can do this in range of length of q q.append, or I guess we could do, now we could traverse the for every and in as neighbors in graph cur. We can graph dot neighbors dot append, or q dot append neighbors, right? And then I assume if we don't return out early, return true, right? I think there's a decent way to solve it. Let's run this through. So we'll have 0, 1, 0, 2. So it'll be 0 we'll have it'll go from 0, 1, 2, 3. 1 will also go to 0 and 4. 2 will also go to 0, and that's it. And then 3 will go to also to 0, and 1 goes to 4. So this is how the graph looks. Basically, I can visit every single node from a given source, so I think we're good, right? And that's a valid tree. If I can't, oh no, that's not true. This is bad. Basically, if I guess, wait, hold on. This is a tricky one. Basically, if we have visited n-1 nodes, okay, I guess we could say if, or return if length of scene is equal to n-1. That's what we really are concerned about. So, just 1 second. Okay. Okay, I see the issue now. I can do this instead. So we can like do all this here, right? Also, I should adjust my data structure. Which is to have parent. So right, just like have cur and pair. So that when we go and traverse, we can return early if the parent has been seen, or not the parent. Skip it if we've seen the parent, you know. So yeah. I think we're good here. So we can do that. Now we just need to add current. Yeah, current. Scene.add source, I guess. Actually, we don't even need this scene, to be honest. We just need it created. Yeah. Okay, once this is done, we need to add append neighbor. We'll do the neighbors, and then cur, or yeah, cur. That's gonna be the parent. And if we see the cur, right? Cur in scene, continue. If neighbors in scene, then return false. Yeah. So that should be something like that. Let's try that. Oops. Should call this again. Got a wrong answer again. False. Expected true. Okay. Oh. Oh, I'm stupid. Okay, that makes more sense. So it's cur and pair, and then we say a pair in scene, and then yeah, if neighbors in scene, yeah, let's try that instead. Still, okay, that's really bad. If pair in scene, oh no, oh yeah. Yeah. If neighbors in scene return false. Alright, what am I doing wrong? Let me look at the solution. Okay, we're pretty close. If neighbor in visit, yep. Oh, we only do it once. We don't need to do it. Oh, okay. Well, that's unfortunate. So. We just do it once. Let's try that. I can say source. Well, I guess how do you start with the? I guess 0. It makes sense. You can start with 0. I gotta go soon, so hopefully this could pass. Brought the. That's really weird. Oh my god, no. If the neighbor is in the parent, yeah. If the parent equals the pair equals neighbors, then it's continue. Yeah, that's what I meant, yeah. Okay, that's really bad. If neighbors in visit, then add the neighbor. And neighbors and the current. Yes. What am I doing wrong? Oh, okay, I should not be running it for this many times. Yeah. Okay, still? What am I really? I'm so confused. For neighbors in graph cur, if power equals neighbors, yeah, if the parent equals neighbors, if neighbors in then return false. Length of scene equals n. Q dot pen C dot. Yep. I'm doing UV edges. UV. VU. Okay, also I should consider the edge case of if length of edges is greater than n minus 1, return false. Maybe? Okay. I'm returning false but expected true. If neighbors in scene return oh my, wait, what? No, okay, it's the current and parent. For neighbors in current, if parent equals neighbors, continue. If the neighbors in the scene, return false. Then I guess we'll add first the current. Oh, not the current. We're supposed to add the neighbors. Alright, there you go. Alright. Thanks for watching. I'll see you guys for wrong. Peace.